Alright, well the reason why I had to pause my video is because Mr. King so rudely interrupted me and told me to go home. But I've got to finish this video. So you've got your opposite side from your angle. You have an adjacent side. And if you don't know what adjacent means, it just means next to. And then lastly, we have our hypotenuse. So if you remember from geometry, the hypotenuse is across from the right angle. Alright, so now you've kind of got a gist of what we're going to be talking about here. So whenever I say sine of theta, I mean the opposite side over the hypotenuse. When I say cosine, I mean adjacent over hypotenuse. And when I say tangent, I mean opposite over adjacent. So let's do this practically, because that might be a little bit confusing. So let's actually put some values in our triangle. So let's make our opposite side 5, our adjacent side 12, and our hypotenuse 13. And we just did some practice yesterday on finding side lengths of right triangles, and so just so you know, this is a Pythagorean triplet. So if we want to find sine, then that means we're going to look at, I'm going to grab my highlighter, we're going to look at the opposite side, which is 5, over the hypotenuse, which is 13. So in this instance, we could say that sine of theta in this triangle is 5 over 13. And that's it. So we don't even know what this angle is, but we know, because of the setup of the triangle, that sine of that angle is going to be 5 over 13. Now, I told you cosecant is the reciprocal. Basically, the reciprocal functions are across from the major functions. So cosecant is hypotenuse over opposite. So if we were to do cosecant of theta with this triangle, we would get 13 over 5. Hopefully you were ahead of me on that one. And I'm going to go ahead and highlight here just to make everything nice and matching, so you can see where everything goes when you look back at your notes. And that's all there is to it. Whenever you have your triangle given to you, it's really not that difficult. What we want to focus on here is memorizing our trig functions today. So let's find cosine, and let's do the same triangle in all of these. So make your triangles all the same, going up and down. So we're going to have an opposite side of 5, and an adjacent side of, oops, started to write adjacent instead of 12. And 12 for our adjacent side, 13 for our hypotenuse. And then again, opposite 5, adjacent 12, hypotenuse 13. Get used to using those words, because we need to use precise math language when we're talking about these problems. So I said cosine of theta is always equal to adjacent over hypotenuse. So our adjacent side in this triangle, I said it like 5 times already, is 12. So we could say cosine of theta is equal to 12 over our hypotenuse, which we already knew from above. And when we go over to secant, I told you that was the reciprocal function. So secant of theta is a reciprocal of cosine. So it's equal to hypotenuse over adjacent. So if we wanted to find secant of theta in this triangle, it would be the hypotenuse, 13, over the adjacent side, 12. Now, if I'm going too fast for you, definitely slow down and absorb this information, but some of you may just be picking up what I'm laying down so easily. So I'm going to go through this a little more quickly. I'm going to highlight again my hypotenuse the same color as above. And you'll notice that I have to use an entirely different color for my adjacent side because it wasn't used in the ratio above at all. And then lastly, tangent. Tangent is calculated by opposite over adjacent. So when we go to our triangle, tangent of theta is going to be 5 over 12. And again, cotangent, you're probably already ahead of me on this. Cotangent is going to be adjacent over opposite. And so all you need to do for cotangent of theta is just flip what you calculated for tangent upside down. 12 over 5. And one more time, I'm going to highlight. This time, I don't need the blue because there's no hypotenuse in this calculation whatsoever. Highlight all my adjacent sides. And there you have it. So you may be wondering, I'm expected to remember all this? Well, really, if you just remember these three, then these three will come naturally as you gain more practice, as long as you realize they're just reciprocals. So how can we remember these three? Well, I have a little acronym that has been passed down to me from Mr. Kreitz, and it is called SOHCAHTOA. All right, so sine is SOH. So that stands for sine equals opposite over hypotenuse. All right, it's an acronym. And then CA, I'm going to do it all in color. I don't know what I'm doing. CAH, C-A-H, is cosine equals adjacent over hypotenuse. And then lastly, tangent, you can remember by TOA. T-O-A. Tangent equals opposite over adjacent. SOHCAHTOA. All right, so to remember SOHCAHTOA, Mr. Kreitz passed down to me this nifty little phrase. So I want you to go to page 17 in your ISN one more time. And what we're going to do is next to this on the side, I'm going to glue mine right here and I'm going to leave some space. We're going to write some old hippie caught another hippie, wait for it, tripping on acid. Yes, I really did just go there because this will help you remember it so well. Okay? Some old hippie caught another hippie tripping on acid. SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Believe it or not, you will memorize it. And very quickly too. So that's basically it for this portion. So now what we need to do is go and just do a little bit of practice. Because really all I've done is put a whole lot of information in your head. Now we need to apply it. So what I want you to do is draw this triangle. Another right triangle. This only works in right triangles, by the way. Put your theta up in the top left. And we're going to create a 3, 4, 5 triangle. Now what I want you to do is state the 6 trig functions. What I mean by that is exactly what we did here. Whenever we wrote out these 6 items, that's stating the 6 trig functions for this triangle. So that's what I want you to do. I want you to do it for this triangle, and then I also want you to do it again for this triangle. Let's see if I can think of another triplet. I think I know one. 8, 15, and 17. If that's not right, I'm sorry. Shame on me. But I'm pretty sure that's a Pythagorean triplet. Yeah. Okay, so also state the 6 trig functions for this as well. Bring those to class. I'm going to look over them and try to remember SOHCAHTOA. Some old hippie caught another hippie tripping on acid. All right? Good luck.